Hey, graders. Hope everybody's doing well today. I just wanted to take a minute and do a quick demonstration for you to show you the permeability of ground material. Now, that's probably a new word for you, but it sure is important when we're learning about groundwater, which is one of our most important freshwater resources. So I'm going to take you through a couple of things, and then I'm going to do this demonstration for you. So as you read through the PowerPoint that's posted in today's lesson in Google Classroom, you're going to learn about the two sources of fresh water that are available to us for our everyday needs and the needs of several billion people. And those are groundwater and surface water. And so this demonstration is going to focus on groundwater, which of course is water that is stored underground, since surface water is the water that's at the surface. So that's going to be rivers, lakes, and streams. Groundwater is stored in underground reservoirs called aquifers. Aquifers are not tanks underground. They're actually ground materials like rock and soil that are able to hold water. How do we access that water that's stored underground? Well, we drill wells and we pump it up to the surface. So we're going to take a look at three ground materials to determine how well they can hold water and which ones would be the best materials for holding groundwater. So which of the three materials listed here do you think would be best for storing groundwater? Just rank them from 1 to 3, 1 best and 3 worst for being able to store groundwater. So we've got sand and clay and gravel. What do you think? Just rank them. So watch this demonstration and see how close you were to being correct. So here are our three ground materials. We have some sand, and we have some gravel, and we have some clay. A little bit hard to see, but we have some clay. And of course, all of these materials can be found in soil somewhere. So what we want to do is we just want to test their ability to hold water and for water to move through them. So what I've done is I have 3 little plastic cups that I just measured about 1/4 of a cup of water into. And I'm going to pour the water into each of our 3 materials here. And what we want to observe is just how quickly the water moves through those materials. How quickly does it kind of reach the bottom of the cup? So I'm going to start with the sand, and I just want you to observe how quickly, how easily water is able to move through that sand. Remember, you ranked these from 1 to 3, which one you thought would be the best at holding water, and which one you thought would be the worst. So let's see how sand does in the 3. So I'm just going to pour the water into the sand. And if you notice, it moved down pretty quickly through the sand, all the way down through the sand. There's a little standing on top, but it moved down pretty quickly through the sand. Next, I'm just going to pour some water into the gravel, and let's see if you can observe how quickly it moves through the gravel. Well, if you watched, you would have been able to see that it went straight down to the bottom and eventually filled up, and now it's all the way down to the bottom of our cup. So that water moved easily through that gravel and quickly through the gravel, a little more quickly than it moved through the sand, actually. All right, now we're going to test the clay. So I'm just going to pour the water into the clay, and I want you to observe how quickly the water moves through the clay. So if you take a look at the clay, what you're going to notice is that all the water is standing on the top. The clay is not allowing any of the water to seep down through it and get to the bottom of the cup. So water moved very quickly through the gravel. Not quite as quickly through the sand, but it still made it to the bottom of the cup fairly quickly. But then here it is, still sitting on the top in the clay. So the clay is just not letting that water soak in. So why did this happen? Well, the spaces between rock particles are called pores. So any rock that can hold water is considered porous. The more spaces between ground material, rocks and soil, in an aquifer, that's that underground layer of porous, permeable rock and soil, The more groundwater it can hold, the more porous it is. We say it has high porosity. So if you look at the top picture, if you'll notice that the particles are very close together and you don't see much blue space in between them. So not very many pores to hold water. So we'd say that has a low porosity. Probably not the greatest at holding water. If you look at the one at the bottom, notice the particles are further apart and they're kind of more round in shape. And that just allows for more space between the particles. And if you'll also notice, in between the particles, you see lots of space, which are the pores, but notice that they're all connected. And so water can not only fill up and be stored in this material, but it can move freely through this material. So that leads us to our next term, which is permeability. Permeability is just the ability of a substance to allow water to flow through it. So if a substance is permeable, not only can it hold water, but water can move freely through it. So if you take a look at this material here, you'll notice that there's one stream of water going in, but underneath it looks almost like a shower head. So that water, once it goes into this material, evidently this material has pore spaces between the particles that are connected so the water can easily move to each side of this substance and then come out in lots of different places from the bottom. So this material has to be both porous and permeable. So the opposite of that would be any substance that does not allow water to flow through it. And that would be considered impermeable or non-permeable. So when rainwater soaks down, it infiltrates, percolates down through the ground, kind of one of the steps of the water cycle, it's going to keep, seeping down through the ground until it comes to some type of rock that is impermeable. It might be granite or it might be marble, but generally we would call that bedrock. And once water reaches an impermeable rock, it's just going to stop and it will flow sideways and it will just fill up all the permeable material that was above it. So impermeable just means it will not allow water to flow through it. Permeable means it will. So if we look here at this little diagram, non-porous, a material that has no pore space, as we say, is non-porous. And obviously it's not permeable because if it can't hold water, then water can't move through it. A material that has pore spaces, has spaces between the particles, is porous, but in this case, those pores are unconnected. So we would say it's non-permeable. It won't let water move through it. It can't freely move through it. In this situation, we do have pore spaces between the particles, and they're connected. So not only is it porous, but it's also permeable. So this would be probably more like our gravel, and this would be probably more like our clay. Sand would kind of fall in between because water didn't move through it quite as quickly, but definitely did move through it. And then kind of in between, there's another ground material that's called silt, and the particles are just a little bit bigger than clay, but still pretty small. So groundwater stored in permeable rock and soil underground. And so from the most permeable to least permeable of our three substances, gravel was the most permeable of all because the water moved very quickly through the gravel all the way to the bottom of the cup. The sand would have been the second most permeable of the three substances because water, although it didn't move as quickly through the sand, it did still make it in a pretty short amount of time down into the bottom of the cup. The clay would have been the impermeable material because the clay did not allow the water to move through it at all. So these terms, porosity and permeability, are important in understanding how materials move through the ground and how they're stored underground when we're talking about groundwater and aquifers. So read through today's PowerPoint lesson. There's important information in there about groundwater and about our surface water too, about your river basin, your local watershed, and all of that material is going to be really important for you to complete today's follow-up activity on freshwater. Hope you have a super day.